Okay, so let's suppose we are issuing a trip command from IED1 to circuit breaker 1. Okay, so IED1 to circuit breaker 1, right? And message is obviously triggered by something happened in IED1. It detected some fault, so it needs to open that circuit breaker. So we need to send the message. And there is obviously no reliability service in this case, right? We talked about that this will be a goose message and there is no reliability service. So that means we have to do multicasting, okay? But this is how the process will flow, okay? In this case, we know these services, right? So client server communication goes through all the layers, okay? Whereas these ones only go through the link layer, Ethernet layer, and that's it. Then it goes directly to wherever it has to go, okay? There is no reliabilities, there is no other services that are provided by these layers. There's nothing like that, because as we talked, if we try to do that, it's going to cost us time, which we don't have for trip commands, right? So ID1 is going to issue the trip command, okay? So ID1 protection general operation, it's for circuit breaker 1, and then it goes to, you know, the MAC addresses. Basically it appends, and that's it, nothing else, right? And then we have the frame. So it basically goes through directly through the link layer. So this is what will happen. ID will issue the command, okay, for circuit breaker 1. It will go through this hub, has no intelligence. So it's going to send that information everywhere, okay, because it can't route. It has no idea where to go. So it will send to this ID, it will send to the switch as well. So whatever, you know, is connected, it will. So this ID will receive it and it will interpret it, and it knows that it's not for it. You know, the information is actually for circuit breaker 1. So it's going to just ignore that. Then it will go to the switch, okay? And because it's a multicast, it's a goose message, there is no information about routing. Although this switch may be intelligent, it can interpret if the routing information is there, but because we don't access that layer. So it's not going to go there. So this message will also go through everywhere, okay? So it will go here, and through hub, it will go to these two devices. Obviously, they will ignore it because it's not for them. This HMI will ignore it. Here, it will go to these places. They will ignore it. Eventually, circuit breaker 1 is going to recognize that it's for it, this, because it has its MAC address, right? So then it's going to basically strip that information, right? And it will know that it's to open that circuit breaker, right? That protection is meant to open that. So this is how the circuit breaker will be opened, okay? Right? So, and depending upon, you know, sometimes they have the MAC address, sometimes they may have only destination device ID, depending upon how you set it up, right, for recognition. But that's how it happens. So sampled values are similar, okay? The only difference is, you know, sampled values are transmitted continuously, whereas goose is only initiated by somebody, right? And also, there is no multicasting. Whereas in goose, you can multicast. You can send the same message again and again, right? So let's say we want to transfer samples from ID1 to ID4, because same data can be used by ID4, for example, for differential protection, right? You need data from both ends of the line, right? So, and also there is no reliability service, no multicasting, right? So ID1 to ID4, right? So this is what will happen, right? So you start with the instant magnitude of voltage or current, whatever is, append the ID4's address, MAC address, right? And then you send that message. And same thing will happen here too. ID1 goes to both places. From the switch router, same, goes to all places. The only one that will recognize this is ID4, and it will strip that information out of, it will go in the reverse direction, basically. It will find the instant magnitude, right? So this is, again, very simple processes that happen. And then client-server communication, let's say we want some energy values transferred from ID3 to HDMI, okay? This is a reliable service now, okay? It's going to use all the layers, but each layer will add its own overhead, okay? And it will increase the message size. So ID3 to HMI, right? So this is, let's say we are doing the total bots. MMXU is the logical node for measurements, right? And this is the total bot value. And then HMI IP, okay? And then TCP will add its own overhead, okay? IP layer will add its own overhead, and then eventually the message will become very long, right? That's what will be transmitted. But it has now reliability services, routing available, and all that, right? So this is what will happen. ID3, because this has no intelligence, so again, it will go in all directions. But the switch has intelligence now because it has the information where to route it. So it will only route to HMI, and at HMI, it will be stripped, right? And eventually, you will get the value, okay? So very simple process, okay? Now, with these, you can do peer-to-peer communication, on the station bus, for example, devices can talk to each other through goose messages, okay? They can initiate any goose message they want, right? And you can share configuration data also using the same set, although we didn't talk about configuration, but you can. Actually, we have done some work where just by changing configuration data, we can change the nature of ID. Okay, there are two papers that we have written. This was the work we did for Hydro One, our transmission utility. So, for example, one of the IDs goes bad. Its functionality can be transferred to another ID or a spare ID. And you can do that through configuration. Because remember the logical nodes, because logical nodes are the ones that provide functionality to any ID. So if you can just change the logical node, then you can change the functionality. So logical node could be protection, measurement, breaker. So you could, rather than having a breaker, I can put something else in there, right? So you can actually change that, and you can do that on the fly, right? So, but you can share that information, and there are, this is what I was saying. Most of the substations have now. They have hardwired to IDs from the breakers or from the CTPTs. At the station bus, we have the IEC 61, but this is where we want to go also. Process bus also should be IEC 61850 compliant, and it should be networked. So then you can share all this information from anywhere with everything, right? So any possible architectures, you can have. So this is a star station bus which is connected in star, right? So these are hardwired, conventional, but this is your station bus, which is connected in star. You can connect in a ring bus. So any possible architecture that you can think of, or you can have a combination. Part of the station bus can be star, another part can be a ring, right? Here, you could have modern CTBT going directly to the relays, the sampled values, right? And then rest is all conventional. So you can have a combination of that, right? And this is breaker ID directly to the station bus. right? So any possible, combinations you can have, right? Depending on, and this is 2 process buses are there, right? Connected in a star. And then they are connected to the ring bus, which is your station bus, right? And right. So best configuration that you decide can be, yeah. You can, so it all depends how you configured your system, okay? So ID can be configured to receive data from only particular devices, particular IDs, so that it's not overwhelmed, right? So you can configure that. So that's configuring your communication. And the tool I was talking about, it will allow you to do that. Okay, so ID have a specific file, okay, which will define its capabilities, and also you can configure who can access the data from that ID. Okay, because you don't want to, every ID have access to everything. I think that will be too much. Although you can, but it probably is not very good idea. So you only decide, you know, the few IDs you really need to share data, then you can do that. And that's why sometimes you divide the process bus also, right? Because you only need that type of data from those devices. So you divide them. So again, it's up to you. It's very flexible. Okay, this is why I say, we are, they are all unique in a similar way, right? So it's they're all following IEC 61850, but they're unique. You can have any unique combinations, right? And setting up this one doesn't take very long. With that tool, you can set up the whole substation, in few hours, compared to what they do now, right? With hardwired and so on. So this is the summary. So this is a little bit of additional information. I talked about the message types, uh, various message types that are there, right? Time, transfer time, and so on, whether it's critical or not, right? So, uh, so those are again some of the. I don't have a map here. I think it may be somewhere another presentation. I have a map of the world where what countries have adopted IEC 61850. So the mandatory ones, where it's mandatory, India is actually one of those, where all the IDs, new IDs that are coming in must meet the IEC 61850 standard. China is again another one. And very interestingly, where this standard originated, it's not mandatory there. Canada, US, not mandatory. Although they're using it, but it's not a requirement for devices to be there. Europe, some portions, it's mandatory, uh, but not everywhere. I don't have that map. It's very interesting map. But whether it's mandatory or not, almost everywhere it's being used. And not only that, I don't have the slide. It has been extended to other areas. So for example, DERs are now using that, okay, especially wind is using it. Gas industry has started using this one, okay. Um, there are other applications, and they have made their own standard because the data models we talked about. The ones I described are specifically for power substation application. But if you can extend your data model and add your own data models, then you can have the same concept for any industry. It doesn't matter, right? So, okay, so I think that's all I had for this one. What I want to do now, yeah, we can stop unless you have any questions on this. Everyone is okay? You are all IEC 61850 literate. Okay, great. Because remember this, we are going to be using this information later on. Okay. Yeah. So what I want to do is there is a presentation. Oh, actually, we have to pull it out of my laptop. Let me see what is there. What was there? So we are going to talk about basic foundations of cybersecurity, and I will spend most of the time on public key infrastructure because um, all the standards we are going to talk about for cybersecurity, especially for substation automation, are using the PKI, okay, public key infrastructure. So it's important to understand the basics. And there may be some information that I will skip over very quickly, but we will. So this one, I think we already talked about. Dr. Walza talked about that confidentiality, integrity, availability. So I don't need to repeat that. You know, why cyber attacks are important, don't need to repeat that. And then we talked about the common threats that are there. So I'm going to skip all that, right? Ransomware, phishing attack, uh, authentication. So this is where we will start. Encryption is very important for cybersecurity, but later on, I will tell you even there are threats to encryption right now, okay? Possible threats in the future. So it basically converts the readable data into unreadable data. We call it ciphertext, okay? And we obviously require a key to decrypt it and key to encrypt it, and data in transit. So there are two types of data, you know, static data, which is stored data. We need to protect that, as well as data in transit. Need to protect that also, and data at rest, right, which is stored in servers and this encryption and PKI is also the foundation for VPNs, which are very commonly used, okay, and secure messaging as well as secure storage, okay. So as I said, this is the fundamental to all cybersecurity solutions that are currently available, that are being used in industry, okay. So it's very important. So there are two types of encryptions. One is symmetric encryption, which basically uses a single secret key, okay, to encrypt, and you need to have the same key to decrypt, okay. So, and the common ones are, there are algorithms which we are not going to talk about the details of those, because as I said, that's a separate topic by itself. You know, what are the various encryption algorithms? Okay, I will show you some examples. I have written some Python code which I will run and show you how it looks like, right? So AES, Advanced Encryption Standard, and then DES. There are, you know, AES is very common, okay? And key distribution is a major challenge, as you can understand, right? If, um, people got hold of the secret key, then obviously your encryption doesn't mean anything. They can get that. So this is the issue with symmetric encryption. And then we have asymmetric encryption, which is very commonly used now, okay? Where we use pair of keys. One is known as the public key, the other one is known as the private key, okay? So it will allow the secure communication over untrusted networks. You can do secure communication, and I'll give you examples. Later on, we will talk about it. So right now, with this presentation, we are doing an overview of the whole thing, okay? And it's used in digital signatures, okay? You can digitally sign a message, okay? And you will do that, you know, with your private key, but with your public key, anybody can interpret that message, okay? But nobody can change it. They can't change it. They can get it, interpret it, but they can't change it. And the examples of asymmetric encryption, RSA, ECC, curve cryptography, there are many algorithms that are used, and there are standards algorithms that are used. Actually, there is an organization in US that takes care of all these encryptions. Okay, you can actually come up with an algorithm and submit to them that I have come up with this encryption algorithm and submit to them. They will take a look at it. If it is good, then it becomes part of the standard, their standard. And right now, they have just done one which takes care of quantum computing. Okay, we will talk about that, the threats to some of these encryption methods. Okay, so what are the digital signatures? Okay, this is again, we will tie this all together through examples later on. Okay, so digital signature is a way to verify authenticity and integrity of a message document. It's like, you seal it and you sign it. Okay, so once you see it sealed and signed, you know it's authentic, and you can trust it. Okay, so as I mentioned, digital signature is created by sender's private key and verified with their public key. So everyone, think of the device, ID. They will have their private key and they will have their public key. Okay, and it will ensure non-repudiation. That means sender cannot deny sending it. That's another thing. If somebody sends some weird message and later on say, oh, no, I didn't send it, I didn't, you can't deny that because, you obviously signed it, right? And it's very common in contracts, software distribution, and secure emails, and also secure messages that we will talk about, the digital signature. Okay, so that's the digital signature. Right now, all we are doing is understanding all these various, aspects of that. And as I said, we will tie this all together. Okay, and then how do you maintain all these keys? Every device has a private key and a public key, right? Senders have, how do you manage that? So this is managed by what we call public key infrastructure. Okay, so it's a system where we manage the digital keys, all these private and public key, and also digital certificates. That's another aspect. There are digital signatures and there are digital certificates. Digital certificates are used, also used for secure messaging, okay, especially to set up a secure communication channels. Okay, let's say, and this is very well used in SCADA, for example. Okay, and we will talk about that. Okay, so what are various components of public key infrastructure? The various components, there is a certificate authority, okay, that issues and revokes certificates. Okay, and then there is a registration authority. We will talk more about these. Okay, there is a certificate database where all the certificates are stored. Okay, and I'll show you an example of a certificate, how it looks like. It's a standardized also. Okay, X.509, I believe. Okay, and then certificate revocation list. So you revoke some certificates, you need to maintain a list which certificates are revoked. Okay, so it's secure, sports secure email. This is where the SCADA, TLS, transport layer security. Okay, so it's mainly to set up secure communication channel. Okay, we'll use that. And it also supports digital signatures as well. Okay, so that's another aspect that we need to understand. So what is a digital certificate? What does it contain? Okay, as I said, it's a standardized document. Okay, it links a public key with an identity. Okay, so you have a private key, you have a public key, and also you have a digital certificate. Okay, so, and it's issued by a trusted certificate authority. Okay, everybody can't issue it. It's issued by a trusted. And what does it contain? Contains the public key. Okay, it certificates holder's information. It also contains the expiry date, and it has the digital signature of the certificate authority, just to make sure that it's a legitimate certificate. Okay, so now we understand the digital signature. So certificate authority will sign this certificate with their private key. But anybody can verify that signature with the public key, with their public key. So they have certificate authority also has two keys, private key and public key, just like anyone else, right? So they can digitally sign this. So this is a digital certificate, okay? All these will come back when we talk about the standards and how we do the secure communication and so on. So get into, remember these things there, right? So this is what I was talking about, SCADA, Transport Layer Security, TLS, okay? It's a cryptographic protocol used to secure data in transit, okay? This is used in SCADA. So there were, I'm sure you heard about SSL, secure sockets. It basically replaced that. It's much more secure than that, okay? And it will provide the encryption, it will provide the authentication, integrity, and we use that in HTTPS. Every time you go to a bank, go do a banking transaction, this is exactly what happens, okay? They're going to verify the digital certificate, okay? That's how you will get in. And also VPNs and, email, secure email, and so on. Okay, as I said, we are going to tie this all together, give you examples so that you fully understand that. And then there are firewalls. I think we all know that. Okay, firewalls are mainly filter the incoming traffic and outgoing traffic based on the rules. They have, certain rules, and based on that, they will. Okay, so there are various type of firewalls. They are used in the power industry, but I think they are not 100% secure. They are another level of defense, basically. Okay. Um, and VPNs, I think we know that, right? Many of us are aware of that. Okay. It basically hides the IP address, and also it encrypts the traffic, right? It does the encryption. So this is mainly used, let's say an engineer is sitting remotely and they want to access, a substation computer remotely, right? So then, you can use the VPN for doing that, okay, virtual private network. So this is basically what we are looking at, the complete system. Firewalls, we will talk about the intrusion detection system in one lecture. Okay, what is that? And then network access control is there. Okay, this is important, security information and event management, right? So many utilities now have that. It basically tells you who is accessing what and what's really happening on your network, right? And then vulnerability scanners. This is where we will talk about auditing. I can actually, we developed a tool way back, many years back, when people were not even talking about that serious about cybersecurity, where we could run that tool and tell you how vulnerable your system is to, cyber attack. And where are the vulnerabilities? Okay, and they have these tools, Nessus and OpenVAS, that you can run on your system and find out where are the vulnerabilities in your system. Okay. Endpoint security, we talked about that. Okay, so it's at every level you have to provide that security, including your laptops, phones, tablets, and so on, right? And this is where the malware usually enters through, right? So antivirus, anti-malware, and so on. So this is, I think we also use on our laptops, and companies, actually the ones who provide operating systems, they provide these type of protection tools for you. We'll talk about network segmentation. For power industry, this is extremely important. You segment your network into smaller zones, okay, so that you limit the spread of the threat, right? So that only one part of your system is exposed, even if it is under threat. So, and I'll give you some examples of that. right? We talked about intrusion detection. So it continuously monitors, and any suspicious activity it will report. Okay, there are various types. You can have a network based, you can have a host based. For example, well, current IEDs don't have the capability to host a intrusion detection system. Okay, so most of the systems are network based. So at the network level, they will try. But I think the future IEDs, and this is where I think work can be done. So those are host based intrusion detection system. So your IED itself will be able to detect intrusion. If right now there is nothing like that. So this is a layered defense, basically. So at every layer, you have to have that defense. That's what it is. Okay. So DMZ, demilitarized zone, is another one that strategy is used. I'll give you some example of that. Virtual networks, and then zoning. We talked about segmenting your network, and then redundant paths and failover. So you can have a redundant network. So if one network you think is being intruded, then switch over to your network, which is safer, right? So depending upon the criticality of your assets, you could do that, right? Demilitarized segmentation, yeah. Demilitarized zone. So these are the zones which are extremely important for you, okay? And you basically fortify them completely, right? I'll give you the examples later on. We will talk about that. What are they? How did you set it up? How did you determine what zone need to be demilitarized, right? And then zero trust security model. So this is again more from cultural point of view. So remember I talked about it's not the technology, it's also your cultural and management. That's extremely important to provide cybersecurity. This is more from cultural. Never trust, always verify. It doesn't matter who it is. The prime minister of the country comes, you don't trust. You say, we have to verify. Sorry, sir, we have to do this, right? This is more cultural thing, right? I hear stories when somebody, it's again cultural, nothing, where somebody important goes to the airport and they basically tell them, we have to check your bags. And they get upset. I'm very important person, right? Why are you checking my bags? So this is what it is, right? Never trust, always verify. That's what it is. So verify every request as if it is coming from a open network. So this is a more cultural thing. Okay, so you will verify the identity, compliance, micro-segmentation, and so on, right? Um, so policies and governance, this is more management side, right? So it defines the rules and procedures for data protection, key policies, right? More harder you make it, better your cybersecurity will be. Okay, so and then you have to have incident response plan, fully data classification policies, what is important, what is not important, classify them. Okay, actually NERC and some other standards actually want you to do that. Want to define what is important, what is the most critical, what is the least critical, and based on that, you provide the security, right? And that's where it supports the regulatory compliance, because now utilities have to be compliant with some regulations, right? So they have to start doing that. And this is the incident reporting plan, right? This is again very much management side. We are not going to talk too much about this given the time, but it's equally important. We are going to focus more on technology side, okay, in this course. So for example, post-incident review, what really happened when an incident happened, why it happened, where was the weakness, and how did you fix that, right? So idea is to minimize damage and recovery time, right? Training, very, very important, equally important. Training of everyone involved should be there, right? So that's another part of the management side, right? And data loss prevention, this is very important too. So you always back up, right? Even in our own personal lives, we back up our computers and say, in case I lose this data, I have a backup. I can restore that. I can tell you personally, it has happened to me. I was, somebody, jammed my computer, right? I think it happened through the university network, right? So they basically, encrypted my files and I think demanding money. And then I took it to our, IT people, and they had the backup data. They said, you will lose only 1 day work, right? We have everything back up. So they basically backed up everything, and that's it, right? So if I didn't have it, I probably have to pay them to get my data back, right? So data loss prevention, right? And so now everything is on cloud. So cloud security has become very important now, right? So key management is actually, we will talk about that in more detail, okay? And so it's really a shared responsibility between the cloud provider and the user also, right? Mobiles is another one, although we are not going to talk too much about that. But nowadays, smartphones and tablets, they are really for malware, theft, and spying. As they are everywhere, and there are so many cases we hear, that people got scammed via there because of the smartphone. They answered something, and right. So there are remote wipe capabilities that are there. Screen locks and biometrics are there, right? Uh, so, so compliance and regulation, there are, organizations which are required to meet the industry standards. And for power industry, it's no different. Now they have, you saw in the first presentation, all the compliance regulations that are coming up that has to be met now, right? So social engineering attacks, this one, and we have seen even in power industry, the blackmailing, right? So employee with, privileged access could be blackmailed, right? And they end up giving out the information, and then attackers use that information. So, but those are mainly the state actors, okay, not small cyber criminals who are only after money, but these are the people who are like spies. They are state actors, and now they're blackmailing people to giving them information, privileged information they have access to, so that they can do the cyber attacks, right? So password management is another. I gave you example of IDs, not changing the password. So that's another important thing, having change the passwords and management of it. But those are cybersecurity risk management. So this is where we will talk about auditing. Okay, identify, access, and prioritize your risks at every level in the power system. So identification will be through auditing and, and then accessing it. So you give a value to every possible, scenario. You say, okay, I'm not very good at this, but what is the risk for me, risk level? Okay, so that's what, so obviously you will first go with the high priority risks. If you are just starting out, that's what will happen. Okay, and you have to conduct regular risk assessment. That's another one. Auditing has to be done regularly, because what happens is, let's say a patch comes, there was a security risk, a patch was provided, and this is what very common in utilities. They don't patch. And you know why? I have heard this from protection people. They say, as soon as I change the firmware or do something, my protection gets screwed. I don't want to take that chance, right? So they don't want to go to a newer version. So as a result, there are no patches done, okay? So, they are obviously vulnerable. And this is what cyber attackers actually use, because they know, when a patch is provided, we know that this is a particular vulnerability, right? They know that, and they also know that everybody is not going to apply that patch. So they are going to use that to their advantage, okay? So supply chain is another one. We quickly talked about that, where you have the contractors and you have the supply chain, because so many people are involved in this, right? So it's the third-party vendors and partners. And risk could include software and their own poor vendor practices. Okay, so utilities what have to start doing is basically, looking at their vendors and, really demanding them to have proper cybersecurity, aspects within their own organization, right? So contractual security requirements should be there. And as I said, there were some cases where cyber attacks happened via them. A subcontractor came, connected their computer to the system, and through that computer, cyber attack happened, right? Because their computer wasn't secured in that case, right? Software development is another one. Okay, this is why we have these patches, right? Because when the software was initially developed, it wasn't cyber secure, right? Then they found they have to patch it and so on, right? So that's another area, although it's not threats from current or former employees. Those are insider threats, okay? Sometimes that happens. A disgruntled employee can, uh, try to do the damage, right? So, and access control and employee training. Person has left the company 2 years ago. They still have access, right? So that happens. And so that means, you have to have proper access control there. As soon as they leave, so that's actually organizations sometimes are very poorly managed in that case. Employee is gone, they still have access, full access to everything, right? So penetration testing, this is where, the auditing part comes, and there are tools related to that. And, some companies, the ones, which are very highly critical companies, they actually hire the hackers, okay, just to find out where are the vulnerabilities in their system, okay, so that they can fix that, right? So yeah, so right now there are no matrices. This is another one, measure of performance. Um, although in research there are, people have proposed, and when we will talk about auditing, we have our own matrices that we used, okay? So, but you could use number of incidents detected in a year, time to respond to threats, past compliance rate, so all that. So you can use that as, matrices, how well your organization is doing, right? So, but right now there is standards don't have that. They don't provide. Like we have power system reliability that you must meet 99.99%, right? There is nothing like that in this one. So that's another open area to work in, actually. Okay. So this one, I think we will talk about that. Encryption, quantum computing is actually big now. Okay. And it's very interesting. They stopped using symmetric encryption because the key distribution was hard. So they went to asymmetric one, right? They went to asymmetric one. But interestingly, with quantum computing, asymmetric one is the easiest one to, to break. So they are now going back to symmetric one, because symmetric one, depending on the length of the key, it will take a long time even for a quantum computer to break, right? So, but they are trying to develop new algorithms now for encryption, which they call are quantum computer resistant. Okay, but those are again the future threats. But I think we are not even there. We still have a lot of work to do, even in the other area. I don't know when quantum computing will become available to cyber attackers, but but before that, we have a lot of other work. There is artificial intelligence being used, and research work is done in that area, where you could, in real time, do the threat detection and response, right? So, and even, in the security tasks, it can help, right? Especially the ones that are very repetitive security tasks, okay? And you can actually set it up behavior-based anomaly detection, right? And used in malware. It's not, again, perfect, okay? But it's something that, can be used, and better than nothing, basically, right? And critical infrastructures, we talked about that. So I'm going to, so this is, again, very general for small businesses. Also, remote work. This is, again, people who are working remotely, they have access to, to the company computers and company infrastructure. So there we are people are using the VPNs and TLS, transport layer security, right? Education is important also. So again, um, there are actually, I don't know, in utility industry, are they hiring specifically cybersecurity engineers? I'm not 100% sure how many utilities are actually have positions specifically for cybersecurity engineers. Maybe those who are in utilities can tell me. I'm not sure if there are positions specifically for cybersecurity, right? But irrespective of that, everyone should have some knowledge about the cybersecurity, right? So this is, again, best practices, updates, passwords, multi-factor authentication, suspicious links, which are, click on a link and you have the, right? Culture itself is important, right? So this was very quick overview, okay? Now what we want to do is we want to go back and look at more detail about the public key infrastructure, because that's what we will be using. And we will use some examples, and I have some software programs also. But before we do that, go there, any question? We will need to change to my computer now. Yeah. Maybe just hold on. Maybe I have that presentation here, but for programming, I think I'll need my computer. Yeah. So let's just go to, we can give 5. Yeah. So I have seen companies where they insist that they want to use their own server. So it all depends what type of data you have, what is its importance, right? And obviously you have to look at the cost and what expertise you have within the company. if you feel that within the company you have expertise to set up your local servers and protect them and so on, right? And you have the means, economical means to do it and maintain all those, then I would say that's better. Okay. But if you don't, for example, for a small business, it's very hard for them to, set up this whole infrastructure. Okay. They can use the cloud, but at the same time, as we talked about, it's a shared responsibility to maintain security. The, the cloud company will do their part, but as a user, you have to do your part as well. Okay. So for small businesses and small companies, they use cloud for them. And for the, obviously bigger organizations, they are going to, if they can afford their local servers and they have the expertise, they can do that. And that, in my opinion, is actually better. You are not exposed to outside. Only your internal people have access to it. On that, on your particular servers, yeah, all kind of things that we will be talking about. Any access, who has the access. The best thing I can say is zero trust, verify, trust no one, verify. So all kind of security mechanisms you have to develop. Okay. You are, yeah. Actually, if you are not even connected to anything, you are more secure. Yeah, yeah. Yeah, that's true, because sometimes software companies are too quick to put the thing out, and then they later on find out that there is a vulnerability, so then you have to patch it and so on, right? So, yeah. So as I said, there is nothing 100%. You can't you can't have you can make things difficult for cyber attackers, but you cannot say I have made it 100% secure. There is no thing, just like you can't make anything 100% reliable, right? There is this fan, nobody can, you can make it very, very good, but you can never say it's never going to break, right? So it's the same thing there also. Yeah, yeah. I say that again. I 61850. How many? Oh, in the past on IEC 60. See, the thing is, IEC 61850 substations are not that many, right? There are, so IEDs have been attacked. IEDs are attacked. Yeah, yeah. Which ones are vulnerable? Ah, yeah. So that's the part we will talk about. When we talk about the IDS and auditing, we'll talk about that. But what things you need to observe. Okay, and there are now packages that you can use on the network and actually monitor who is accessing the network, what is being accessed, is it authorized or not authorized. So you can do all that using this, right? So IEC 61850, the good thing is, if everything is good, your IEDs are good and everything, as you have secured that, the only access point is through substation computer from outside. You can't go anywhere else, right? But if your ID itself is compromised, say somebody, changed the setting and they put a USB and USB was infected, so now your ID is infected, right? That can affect your whole network. So Exactly. Exactly. Yeah. So that's where, but if you have taken care of all of those aspects, the only one point where from outside people can enter into that network is through the substation computer.
But we have to be focused on the vulnerability, so we can capture in trafficking or the network.
Yep, you can, and we will talk about that, how you can do this. And there are packages that will actually, we used Wireshark also in our work. Yeah, where you can analyze the traffic, right? And also the intrusion detection system. That will help also if you install that within your, and again, there are packages. It can be done very, very quickly, actually. Yeah, that's why I was asking if you have cybersecurity engineers specifically, related to cybersecurity, then those people can actually do this work. Yeah. Okay. Any other questions? Yeah, you had a question. Sorry? Yes. Yeah. Yeah. So when somebody is accessing anything, any device in the substation, you are not using multi-factor authentication. Yeah, I think you should start using it. That's actually a very basic thing that can be done. And secondly, you can actually, in addition to multi-factor authentication, there are other things that can be done before, um, just like, you can use the fingerprinting, right? You can use even the voice recognition, before you. So it's multi-layer. That's what I'm talking about. So multi-factor authentication, and then all other layers you can add. So I know it becomes a pain, right? Anybody accessing, they are going to say, why I'm the right person, I'm the real person. Why are they asking me to do all this, right? But you have to, you know, if you really want to protect your systems. So there are, yeah, 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 yeah. So I think when the regulations will come in, and you have to be compliant to them, and they are going to be enforced, I think people will start paying attention at that time, right? In Canada, they are becoming very serious about all this, right? And the problem is, as I said, companies, they get attacked, but they don't admit it. So now in Canada, they have started an agency, which is at the federal level, central level, where you can report your incident. So you don't have to go public about it, but at least you can report, and they can then see what happened and so on. So they can study that, so confidentially you can report that. Yeah. Okay. Okay. So maybe any other questions?